All right, recording has started. Bell work is to download this, print it, and save it and use it for Unit 4 and 5. So click on, obviously, your math class, 403B, course materials, scroll down, and download one or both of these. If you click on the Word document, your, Antonio, do we call this OHS or OLS?
OHS, online high school.
OHS, okay. All right. So in OHS, if you click on the Word document, it's going to show like the first page is blank. And that's because OHS doesn't display Word docs that are uploaded. And this is a good reason why I have all of you upload your TGAs as PDF files to avoid this problem. So in the preview of clicking this, it's blank, and there is a download button below the document on the preview page. If you download the actual physical Word document and you open it, it displays fine. All right, the PDF file obviously will show just fine in the OHS preview, and you can print it from there. So you will need this for this unit. And I made this for all of you to save you the time and pain of creating it yourself. So we are starting Unit 4 today. All right, trig identities. All right, so we're going to use the algebra to change the trig expression into a certain form. Dun, dun, dun. All right, so is this unit easy? Well, yes, but actually no. This is not an easy unit. In fact, this is probably, I would say today and then maybe the next 2 or 3 lessons are actually pretty difficult and require a lot of practice. So at first glance, it's going to seem impossible. But hopefully with that trig identity sheet in front of you and lots of practice, these will get easier. So don't freak out too much the first time that you see this stuff, because it's going to be a little overwhelming when you first see it. I can promise you that, at least. But the good thing about this, the first few lessons are difficult, to say the least, but they're not all going to be like this. They're going to get much easier to understand, and don't freak out. Don't have math panic attacks. All right, we are going to be recorded. All right, so today's focus. All right, you may want to read this. That's a lot of words. All right, Antonio, go for it.
All right, so today's focus, we're going to be concentrating on how to use algebra / trig identities to change a trig expression into a different form. We're going to be using identities of trig related to reciprocals, I can never say that word theorem, cofunctions, and odd/even summary. On this lesson, we will not go over and the recording thing came up in the face. That was great. On this lesson, we will not go over the derivative. For that place, I'm sorry.
Where are you at? Sorry.
Right here.
Derivation.
Derivation of any of the identities used today. Some already have been discussed in the course, and others can be simply seen in the content. And that's that. So yeah.
All right. Sorry, I wasn't paying attention. I was crossing off cofunctions because I actually took that out of this lesson. I forgot to change that word. I realized that we actually don't use it for this unit. All right, thank you, Antonio. All right, so on your downloaded sheet, you already have these written down. How cool is that? It's an important page. That's why, yeah. So people who go through these Learn modules before class, if you could do me a huge favor and just confirm the identities that I typed match the ones that are in the modules. I would hate to have a typing mistake. I did my very, very best to double check my my typed work, because the last thing you need is a identity sheet that has the wrong identities. So, but I'm pretty sure I got them all typed correctly, but I'm only human, right? All right. All right, so the quotient, we already know this. We know that tan is y over x, or sine over cosine, right? Cotangent, it just flips, so it's going to be x over y, or cosine over sine. We also know these from last unit. Cosecant is 1 over sine, secant is 1 over cosine, cotangent 1 over tan, and then there's these three, which you can all see. So we already know these from last unit. All right, some new ones. So Pythagorean identities. We got sine squared of theta plus cosine squared of theta equals 1. Then we got the tan equals the secant stuff. Cotangent equals the cosecant stuff. So we're going to be using these today as well. Tan, not tan, sorry, tan. All right. Okay, the fun begins. So these problems, the cool thing is they're not just one way to solve these. There's, well, for this problem, I solved this problem 2 ways. I want to show both ways how to approach this, and some ways are faster than others. Some ways are easier than others. So this is the way that I saw it by looking at the trig identities. And then maybe the way that you see it, you find another way. I don't know, maybe. All right, so we want to find the value of cosecant, but you are only given the cosine of theta equals 1/2. Some of you are like, oh boy, what are we doing today? Why is there so many boxes? Well, so our goal here is obviously to find what cosecant of theta equals. So, that's going to be this last box, right? Where our goal is to find, what does that equal? Yeah, what does that equal? So I think a good way to approach these problems, at least in my mind, and maybe you have a better way in yours, you kind of want to work backwards in the sense that we know we want to find cosecant, but you're only given cosine, right? And we know that like one of the identities, cosine, is 1 over secant, which doesn't really help us because we want cosecant, not secant. So that kind of quick conversion doesn't work. So we have to use maybe 2 or more identities to kind of change things around. So I like looking at the very end, where are we trying to go? And let's kind of backtrack to see how we can get there. So looking at your trig identity sheets, looking at cosecant, which kind of maybe identify which identities have cosecant in them. And we'll start there. So everyone look at your trig. I should have numbered these. So that way you can put in chat like, oh, 1, 2, 3, 4, 5. That would have been smart of me if I would have thought of that. Oh, well, maybe next year. Let me pull up my trig identity sheet too. I closed it. All right. So really, we only have 3 boxes to work with. So looking at the ones that have cosecant, how many do we see that actually have cosecant in them? And yes, the ones that have cosecant squared, those count as well. So I only see 1, 2, I see 3. I see 3 identities. Do you all agree with that? Right. So we're going to probably use one of those. Looks like the one that I used. The one that actually said cosecant. So I use the one that's kind of the maybe the most obvious. Cosecant equals what over what? What is that identity? 1 over sine theta. Yep, or sine x, same thing. So yeah, and that's the one that I saw too. So I was like, okay, so to get cosecant, I now need 1 over sine theta, right? So the problem is, well, I don't have sine. So now we have to kind of remember this is a puzzle. We're trying to figure out what do we need to get the cosecant from cosine. So looking at your identities involving sine, which ones have sine of theta in them? You can go ahead and write in chat. And you can just, instead of using theta, just use x. It's easier to type out. So out of those 5 that you can maybe count that and have sine in it, which ones only have, well, sine and maybe cosine in it? Because you're given cosine. So which ones actually have just sine and cosine? Danica, it looks like you are right. Sine squared x plus cosine squared x equals 1. Yes, remember the ones that have the squared still count. So Antonio, I wouldn't use the tan, and this goes to everyone who saw like, oh, let's use the tan one. Well, the problem with using the tan, now we're having to kind of go back and say, all right, now we're having to look and see which ones, which tan formulas I can use, and you're kind of limited on that, and you're kind of maybe doing circles. It's not wrong. You just might be creating more work to get to where we're trying to go. And the reason why we want to use delete button's not working. This one is because, well, remember, we're trying to find the formula that's using sine, but the other trig functions in that identity, you need to limit it preferably to what we have, which we already have cosine. So you don't want to have like tan or cosecant again for sure, right? We're trying to get away from cosecant. We don't want to have secant, cotangent. Yeah. So we're trying to get to identity where, well, it has sine in it and a given, if that makes sense. So to kind of recap of our path that we're going to take, we're trying to cosecant. We're using the trig identity cosecant, which is equal 1 over sine. And to find sine, we're going to use the formula identity sine plus cosine equals 1. Well, squared, of course. All right. So we good on our selection of identities. All right. Now it's just kind of plug and chug. All right. So sine squared, we don't know. Cosine is 1/2. So we just replace cosine with what it equals, right? And it's squared. So cosine squared theta. So cosine theta is 1/2, and you have to square it. So that's what this means. So when it's squared, you plug in cosine of theta, which is, well, 1/2, and then you have to square it. I know it's kind of weird seeing that squared here versus after the theta, but if it was after the theta, you'd only be squaring, well, the angle, and we actually, well, don't know the angle, and we don't care about the angle. All right. So I see people in chat already put 1/2 squared is 1/4, and that's correct. Remember, when you square a fraction, you are squaring. You can type it in for 1, or You square the top and you square the bottom. 1 squared is still 1, and 2 squared is 4. So that's how you do it by hand. And that's what we get. What's the next step? Minus 1/4. Yep. So 1 minus a quarter is 3/4. If I got $1 and I take away a quarter, I now have 3/4. Money makes sense. You see what I did there? Yeah, my jokes are bad. I'm sorry. All right. What's the next step? Remember, we're solving for sine. What do we do? Square root. We sure do square root. Square root both sides. We get radical 3 over 2. Yep. So whenever you remember, like when you square both sides, when you square a fraction, it's top and bottom. When you square root a fraction, it's also top and bottom. Kind of makes sense. So square rooting 3 is just radical 3. Square rooting 4 gives us 2. And of course, whenever you square root both sides of an equation, you have to have plus or minus. All right. All right. Next, we now know what sine is, which is a good thing. Oh, actually, I said earlier that we're solving this problem 2 ways. We're not. This is actually 2 problems. Sorry. I just read this other question and realized it's not the same question. On the next page, I solve it 2 ways. Sorry. I was confused for a brief moment. All right. So we now know what sine is. So we just replace sine theta with, well, what it equals, which is radical 3 over 2. What's our next step? Remember, our goal, we're almost done. Our goal is to solve for cosecant theta. Flip and multiply. Yep. So we're going to flip and multiply. Whoops. Yes, you do that. And 1 times, well, anything is itself. And then you have to rationalize. I gave the answer away already by showing too much. You have to rationalize the denominator. And doing so, our final answer is 2 radical 3 over 3. And we're done. That's the answer. So the once you actually know your path, the math is easy. The hard part is deriving that path and going backwards like we did in this problem to kind of figure out which identities we're going to use along the way. That's one strategy. I think it's a pretty good strategy for the most part. Another strategy is just go at it. Just do something, and like, I don't know, maybe not having a plan is a plan too, right? Starting here and saying, all right, well, I know I got to use an identity. Let's choose an easy one. And yeah, so I guess another way to go at it. It's really up to you. I think kind of going backwards from the end to the beginning to know the path, and then just plug and chug. I don't know. It's up to you. Think of the unit circle. Okay. Mom, come pick me up. I'm scared. So here's the thing with these problems. The goal of this unit and like this lesson is to solve using identities. And there might be some of you sitting there and thought of this earlier, thinking of it now. There's actually there's another way to actually solve this than using identities. That's actually probably easier. Because when I first saw this, I was like, oh, we can just do it this way, and it's like really fast, and it'll save you like half the steps, and you can avoid all this mess. And yeah, you could do it that way, but the whole point of this lesson is to do it this way. So we had to do it this way. But yeah, you can create a unit circle. We did it last. We did it last unit. Remember, you were given something. You had to use the unit circle. You draw a triangle. You label the sides, and you can derive anything from it. I guess, right? Yeah, we did it last unit that way. And some of you right now are maybe quickly trying to do that method right now to see if we get the same answer, and we do. But you have to know how to do it this way. Sorry. Okay, next problem. What is the value of tan theta given sine of theta is 2/3 and the terminal ray of theta is in quadrant 2? So quadrant 2, if you can visualize that, x and y, positive or negative? X is negative, y is positive. Yep. Very good, Caitlin. And Caitlin's notation, I like that the best, but I understand, Antonio, your answer too. Yeah, but her format was actually better. So yeah, quadrant 2, x is negative, y is positive. So that's going to be useful when we do the work. So this piece is important for that aspect of it. All right, so our goal, I'll get you started on this problem. Our goal is to get to what? What's our goal here? Our goal is to get to tan. Yeah, we're trying to figure out what tan is. All right. All right, so I'm going to give you, I'll give you a minute. Where's my phone at? I'll give you a minute to kind of figure out your path, and then we'll compare. How about that? The minute may not be long enough. Some of these take a little bit of thought, and a minute may not be enough, but that's what you're getting. I think if you like puzzles, you probably like these problems. I think they're neat. All right. All right. So, which identity did you choose? Let's see it in chat. And there may be more than one answer. So just because some of your answers in chat may differ doesn't mean you're wrong. Just remember that. Remember that. Tan x sin x. Okay. One cotangent. Okay. Remember, it's okay to have different answers because there's more than one way to approach these problems a lot of times. Anybody else? Anybody else? Cosine 1 over secant. So, okay. And sine cosine. Okay. Okay. Yeah, so we got a lot of different answers. Some are the same. Let's see what I did. So I used this one. And again, just because I chose this doesn't mean that it makes you wrong. Okay. Now, the work will be different for sure, but the answer in the end will be the same. Remember that. And I challenge you, for those of you who chose something different, try to do it the way that you're thinking of and see if your path was actually shorter than mine. know if thinking like me is a good thing. Sometimes, maybe. All right. So my reasoning behind choosing this, well, obviously we need to know what tan is, and we have it's sine over cosine. So we already know sine, which means, well, I know sine, but now the problem is I need to know what cosine is. So now I got to think of, hey, what's another identity that I could choose that will fill that gap and give me cosine? But when I use an identity, I don't want to choose one that's going to cause me to have another question. Like, well, now what's secant or what's cosecant? I want to try to avoid creating more questions from the identities that I choose. So remember, we know what sine is. So we can choose an identity that has sine and cosine in it. We want to try to avoid identity that has anything more than that. Numbers are okay, by the way. So which one can I use? Sine squared, cosine squared equals 1. I think I use that one. That's the one that makes the most sense. I did. Yep. I sure did. So once we know the path, it should be pretty easy. So we're going to use this one to figure out what cosine is. And once we have cosine, I can plug cosine in here. We already know what sine is. And that way we can figure out what tan is to get to the answer. All right. So we know the path. And the path is the hardest piece. All right. All right. So I'm going to give you. So let's go ahead. I'm going to show what this looks like set up. And I'm going to give you 1 minute to solve, not the entire thing unless you're that fast, but I want you to 1 minute, ready to go, to solve to cosine. I want to know what cosine is equal to. Nice thing about blank boxes, you know how many steps you should take. And guys, the reason why, I hope you don't mind, the reason why I pre-type these out is because one, it's a lot to type out during a live lesson, and two, typed handwriting is better than written handwriting. If that even makes sense. Typed handwriting. Okay, everyone in chat, go ahead and type out what cosine is equal to. Rad 5 over 3. Plus or minus? Yep. I think that's right. So one thing I want to point out is quadrant 2. So in quadrant 2, I asked you earlier, what's x and y? And, we agreed that x is negative and y is positive. So we also know from last unit that cosine is your x. So what should this sign be if cosine is x? Cosine is negative in this case, yep. Which I do in this following step here, which I plug in. So we know what sine is, we know what cosine is. We're going to go ahead and plug it in. Well, that's funny. Never mind. All right. It's not funny. Math is serious, guys. All right. Sine is 2/3, and cosine is negative radical 5 over 3. All right. I'm going to give you all 10 seconds to, well, I was kidding. I'll give you 30 seconds to finish this part of the problem. 30 seconds, go. Two rad 5 over 5. So someone says negative 2 rad 5 over 5. 2 rad 5 over 9. 2 rad 5 over 5. Let's see what we get. All right, let's see what I get. I got negative 2 rad 5 over 5. Whoa, what? What? Let's find out. So we should have flipped and multiplied, right? Oh, so Emily, your mistake was you didn't flip that fraction. You know what? I don't know if it was you, but I remember seeing somebody did the same mistake on their TGA. They didn't flip. They multiplied the fraction, but they didn't flip it. You typed it in the calculator. Did you put them in parentheses? The top fraction in parentheses divided by the bottom fraction in parentheses. It does matter. Yeah. So if you don't put parentheses and you just type in, you just go in like a long chain, 2 divided by 3 divided by radical 5 divided by 3, and don't forget the negative, of course. The math that you're actually doing is very different. You've never had it matter? Well, maybe you did. You just missed all those questions. You just didn't know it. No, it does matter. Rude. Sorry. You say rude, I say truths. Which I should probably apologize. I apologize if some of you misinterpret my emails as being rude. I'm just very straight to the point. I hate writing paragraphs. I'd rather emails be like bullet points and phrases than actual full sentences and paragraphs. But words hurts my eyes. So that's why emails aren't necessarily great. Anyways, I digress. Why? Oh, did I not? I didn't even show the work for this. All right. All right. So, yeah, and then you have to rationalize. That's something we can never forget. And that's how we get negative 2 rad 5 over 5. We're starting to develop pre-calc. Class love. You say love, other people say hate. Oh, lore? Oh, lore, not love. All right. Any questions so far in these first 2 examples? So to kind of recap these, try, a good strategy that I like is kind of going backwards to determine your path. Once you know your path, it's plug and chug. I think that's a good strategy. If you know of a better strategy, feel free to, if you think of it later, as you're doing this, the next 2 days, today and Monday, you think of, hey, this way might be better, let me know, please. I am always open to suggestions and learning new things and being taught new things. So, okay, so this problem, It's split down the middle because I solve it two ways. The way on the left looks like I'm only using two identities, right? Because the green boxes kind of give it away. And on the right, well, it looks like I'm using three identities because I have three green boxes, kind of a giveaway. So it's just my way of showing there's more than one way to approach these. So I'm going to give you. Wow, we are so uh, we're on page 9 of 17, and it's 10:42. So I'm obviously going to go over time, and I know a lot of you have electives today or stuff to go to. So if you have to go, it's fine. Just watch the recording later. I don't want to stop in the middle of it. I'd rather spend more time being thorough than rushing through it and hoping for the best. You know? Yeah. Okay. So I'm going to give you. Let's do this. I'm going to give you 2 minutes to figure out your path. You don't have to do any work. You just got to figure out which identities you're going to use to get to the answer. And then in 2 minutes, we'll see what you came up with. 2 minutes. Oh, time is up. Oh, goody. All right. So what did all of you choose? So we'll go from forward to the end. So what did you all choose for the first one to use? Remember, there's more than one answer. So what's the first one? Sine squared, cosine squared. Anybody else? Same as, okay, same. Okay. Emily's not sure. So if you're having a hard time going backward, like from the end to the beginning, you can just go at it and see if you can just do work to get to where we're going. Driving blind, flying blind. I don't know. What's the expression? Yeah, I shouldn't drive either. I can't see. Yeah, shouldn't. I drive like maybe once a week, if that. I try to avoid it. It's dangerous. All right. Yeah. So I did the same thing. Another way we could have done it is this way. Cosecant is 1 over sine. So looking at this first way here, if we did this way, well, we already know sine. That's why we used it, right? But now we need to know what. Now we have to figure out cosine. Or not figure it out, but we're going to use it in the next step. So the next identity that we choose needs to have cosine in it because we're going to know what cosine in it is. And preferably one that has cosine and sine because we know what both of them are. And we're using that one. Remember, our goal is to go to tan, right? So talking backwards from the end to the beginning, we want tan, and tan is equal to sine over cosine. We already know what sine is. We need to know what cosine is, and to find cosine, we use this identity because it has cosine in it, and we already know what sine is. So there's that path. Anybody choose this path like me? Who here chose that? Yes, we did that. All right. Anybody else did that path? You did the right side? Okay. Yeah, it is. It pretty much is what we just did, but now, yeah, this is kind of like the same problem as last, but instead of giving you cosine, I give you sine. But in that sense, it's the same thing, right? You're just given the other one, so yeah, it's more or less the same work.
Dr. J, that is the example we just did. Like
Exact
you
same
made this
problem?
sign last time, yeah.
No, don't. It's not the same. It says cosine. Cosine is a half. See,
No,
cosine.
the one on the right. If you look at the problem on the right of the last slide, is this one.
That's what I did. That's okay. That makes sense. Sine is 2/3. Oh, it's the same. I didn't change it. Oh, okay. Thank you for. You feel great. All right. So yes, it is the exact same. All right. So the other way to solve this is this way. So it was that problem. No, I wrote these lessons and I obviously forgot what I was doing. All right. So another way to do this problem from the previous slide, which is also shown on this slide, but on the left-hand side of the column. Tangent. We could have used tangent is equal to 1 over cotangent. But now I need to know what cotangent is, and which means we have to use this identity, which has cotangent. But now we need to know what cosecant is, and cosecant is 1 over sine. And we already know what sine is. So you solve this for cosecant, you plug it in, we solve it for cotangent, we plug it in, and then we find tan. Oh boy. Do any of you want time to work this problem out? Or should I just show the work? Oh, please? Okay. Yep, it's just for it's good practice, right? 2 minutes to finish it up. I know it's not a whole lot of time. You probably need like 4. I'll say, how about 2.5? Unless all of you in chat say you're done. So when you're done, just go ahead and say you're done in chat. But I put 2.5 on my timer. You know, we're already going to blow over our time by a lot, so might as well just keep going, right? So, this problem is cool because you know what the answer should be. So if you're done and you got the same answer, you probably did it right. Cotangent, you got rad. Well, what's rad 1 over 2? What's the square root of 1? Oh. When I say it out loud, it makes sense, right? Yeah. One thing that I do that is a good strategy for doing anything you're learning is talk out loud. When you're working out problems, I know I do. I talk out loud to myself when I'm actually working out math problems. People may think you're a little crazy, but who cares? Who cares? Okay, so we definitely know what the answer is because it should be the same, right? All right, so we plug in 1 over 2/3, and we have to flip and multiply, right? 1 times 3 over 2. Well, it's just 3 over 2, so that was easy. Then we plug in what cosecant is. And hopefully you showed your work just like this. When you square a fraction, you square the top and the bottom. So we got 9 over 4. And then we do what? What do we do? Subtract 1. Someone said, what happened? 3 over 2. Oh, did you mess up this right here?
No, I messed up right here. Instead of subtracting it, I added the 1.
It's
If
okay.
you ever want to use that as an example, I got 2 radical 13 over 13. That could be one of your wrong answers.
Yeah, you want to subtract it both sides. One thing I don't do in my lessons is I don't physically write -1 both sides, and really you should. For good practice, you should show -1 both sides, draw a line, and then you have your next step. The reason why I don't do it on here is because space is limited, and one feature that I wish they would implement is the ability to extend the page down and allow me to scroll. That would be amazing. Amazing. You think it's revolutionary, but it's not. So, there's software called Smart Notebook that I used in the classroom when I taught on a smartboard. And I was able to hit a button that says expand, and it allows me to go down and have scroll bars. And I was able to keep writing and keep scrolling, keep writing. So the problems were, top to bottom as far as I wanted to go. I know. Anyway, so we subtract 1 both sides. 9/4 minus 1 is 5/4. Then you square root both sides, and that's how you get rad 5 over 2. And it is plus or minus. We are in quadrant 2. So because quadrant 2, y is positive and x is negative, well, that means cotangent should be what? Negative. Yep, cotangent should be negative. Because we are in quadrant 2. but we won't worry about it until the end or the next step at least. All right, so we now know what cotangent is, and I plug it in. I had a plus or minus right there. You can kind of see I covered it up last second just because I just wanted to show it as being negative. Just because we're in quadrant 2, so we know y is positive, x is negative, therefore tangent and cotangent must be negative in quadrant 2. So, but if you put plus or minus here, it's really not going to matter until your final answer, which it better be negative. If you put plus and minus here, it would be wrong. All right, so just like before, you flip and multiply. And then you have to rationalize. And then that's how we get negative 2 radical 5. So I'm going to uncover this. So like, yeah, if you did plus or minus like I did originally before covering it up, in the end, you need to know it is just negative because we are in quadrant 2. All right. So this was another way to solve this problem. I would say this way was longer and probably not as easy than this way here. I would say a good rule, if you're using more than 3 identities to get to the answer, you're doing too much work. Most problems should only take you 2 identities, 3 max. I would say that's probably a good rule for this class. Hopefully that's helpful. All right. Any questions so far? Maybe like when is this going to end, right? When's it going to be over? All right, more identities. All right, odd even identities. So these are kind of fun. These are useful when your sine, cosine, tangent, or whatever, you're dealing with a negative theta. We use these identities to, well, make theta into a positive theta versus a negative. And this is the conversion, the identity for that. So that's what the use of this is for, is when this is negative. And that's when you know when to use it. All right. All right, we want to simplify. So more problems using identities. And these we really know from last unit. What is okay? And for these problems, you really want to get everything in terms of sine and cosine. So that is really an objective here. Is if you have secant, cosecant, cotangent, is rewrite them in terms of sine and cosine. And that's how you want to start these. So how can I rewrite secant? One over cosine. Yep. Secant is 1 over cosine. I think I said yesterday during the review that all of you should know sine is y, cosine is x, tangent is y over x. Secant is 1 over cosine. Cosecant is 1 over sine. And cotangent is cosine over sine. Okay, I said that right. But you have the paper in front of you if you just happen to forget or you want to confirm. All right, what is cotangent equal to? I'm sorry. Ooh, did I do this wrong? Oh, I did it right. No. Uh-oh, my work is wrong. Oh no. Messed up. Uh-oh. All right, what is cotangent? Um, 1 over tan or what else? Oh, I don't have it on the sheet. I do not have it on the sheet. Oh, well, I don't have the sheet. Okay, that's okay. Oh, I do. Yeah, I do. It is on the sheet. Yeah, cosine over sine. So, I wrote it wrong. Dang it. So mad at myself. All right, we're not going to show the work for that one. We're just going to redo it by hand. I messed up. I wrote cosine. I put sine over x by accident. So we're going to just put white boxes and we're going to fill this in properly. Everything is wrong here. Everything is wrong. Okay. Doing so good at not making mistakes, everyone. All right. So we said cotangent was cosine over sine. Right? So that's what should be there. And then you flip and multiply. So that means sine goes on top. Cosine goes on bottom. Mm-hmm, mm-hmm. And then, let's see, let me check out the identity sheet again to see if there's another way to write cosine squared. Nope. I could write cosine squared as 1 minus sine squared, but that doesn't, I won't do that. Dun, dun, dun. You know, I wonder if I meant to actually put cosine or tangents. Oops. Because the problem isn't going to work out very nice in this example. I think I did. It's all right. All right. So the answer for this one, we want to write as a non-fraction answer. So I can't really do a whole lot with this other than we already know 1 over cosine is equal to secant. So I'm kind of going back to what we had originally. Secant, and then sine over cosine is what? What is sine over cosine? Tangent. So this would be an answer right here. Your simplify secant x times tan x. That answer works. Technically speaking, I guess you could say sine x over cosine squared x. That would also technically be an answer. That's simplified. But I really wanted, so hopefully all of you wrote this down because I'm going to delete it all. I'm going to show you what I actually intended this problem to be. Let me get my eraser out. Everyone got this written down? Dun, dun, dun. All right, I'm going to erase it. My eraser bigger. Antonio, help me erasing stuff. Help me. Too slow. It's already done. Okay, so I intended this problem to actually be a tangent. All right, so I meant for this to be a tangent of x. Okay. that's, well, okay, I'll just use thick ink. Tangent of x. And then there's the work for that. Tangent is sine over, oh, my pointer's messed up. Hang on. There we go. Sine over x, flip and multiply. So cosine goes on top. And then cosine and cosine cancel out. So in this step here, I would just do this. And then you're left with 1 over sine. And then I can rewrite 1 over sine as cosecant of x. So that's what I intended this problem to be. Whoops. Sorry. All right. This next one here. So I'm going to give you all 2 minutes for the second one. And remember, our goal is to get everything in terms of sine and cosine and see if we can combine everything and then rewrite it as an answer that is not a fraction, basically, if possible. So go ahead. I'm going to give everyone 2.5 minutes for this one. Ready to go. Okay, what is the final answer? Final answer, what did you get? Nobody has a final answer? You just got 2? Oh, just 2. So your final answer should have like a trig function in there, like sine, cosine, tangent or something. There shouldn't just be a number. All right, cotangent of x. So let's take a look. Is close. I got 1 plus cotangent of x. Okay.
I misread the cosecant in the second part, the cos x times cosecant. I misread it as secant, so I thought it was just the 1 plus 1.
Oh, that's something I would do. No worries. Yeah, if you misread those, it's easy to, right? Because they're all kind of very close in a way, and if you write it wrong, it changes everything dramatically. So I can see why you got 2 then. All right. So all of you should have written sine times, well, cosecant is 1 over what? 1 over sine, yep. So all of you should have had that for your first term. All right, the second term, cosine times, well, cosecant, well, again, same thing, actually. 1 over sine, so that was easy. All right. Sine of x times 1 over sine of x, well, that's just going to be 1. And what did I do? Oh, I didn't. So we could actually cross out. So sine of x and sine of x cancel out. And that's probably how I would have done it if I didn't type it out, because then you just get 1 here. But I showed sine of x times 1 is sine of x over sine of x. And then dividing by itself is just 1, so that's why it becomes 1 here. And then cosine of x times 1 over sine of x becomes cosine of x over sine of x. And we all know from the identities that cosine over sine is cotangent. If that was sine over cosine, that would be just tangent here. So that's why the answer is what it is. What's your question?
So how come for the sine x and the cosine x, we didn't put 1 over cosecant and then 1 over secant?
Point to it with your pointer.
Like, hang on. Wait. Like sine, how come you kept it as that instead of putting 1 over cosecant? And then for this one, how come you didn't put 1 over secant?
So let me write this down. So yes, that first one, I could have written it as 1 over cosecant cosecant of x plus, and then you're saying write cosine of x as 1 over secant. All right, so if you did it this way, this cancels out, and then you have 1 here, and then you're going to have cosecant of x, and then secant of x. So you're kind of creating more work for yourself by doing it this way. And I don't think we have an identity that shows us cosecant divided by secant, do we?
I don't think so, but I'm just confused. Like, so are we supposed to do every other one, not all of them?
No. So remember, our strategy for this one, our goal for this one, is to get everything written as sine or cosine. So that's why I only rewrote this one and this one, because these are already sine and cosine, so I don't have to change those for my next step. So now once we're here, everything is written as sine or cosine. And that's what we want. Because then usually from here we can combine stuff somehow, cancel stuff out, and that's what we did. Does that make sense?
Yeah, so then the sine x over sine x, that canceled out, and then we have the cosine x over sine x. And then how did you get 1 plus cotangent x?
Yeah, so these cancel out. And so, for example, if it was like 5 divided by 5 is what?
1.
Yeah, and so sine of x divided by itself is also 1. So
Oh,
that's where that 1 came from. And then from your identities list, if you look, cotangent of x, or theta, or whatever I have written on the sheet, is equal to cosine over sine. You see that on your sheet?
okay, yeah, that makes sense.
Yep, and that's why that part becomes cotangent
Okay.
of x. So, this is one reason why I don't like working left to right. It saves room, but I personally like doing math top to bottom, but we don't have a whole lot of room usually. But yeah, so there you go. It's a good question. Any other questions? It's a good, man. Top to bottom is the way to do it. All right, good. Okay. Ooh, all right. Chugging through these. So your test, your quiz, you may have problems that say verify. Seems kind of confusing, but you're going to use identities to get from the starting point and then to get to the end point. So our goal, when you verify this is true, you're trying to get the left side to equal the right side. So they'll give you this, and I think on your quiz or your modules, they kind of, I don't know if it's empty box, I forgot how they present it, but they're basically telling you we want to make both sides the same, right? That's how you verify the identity. So all the way through this, you're not changing the right side of the equation. You just leave it alone. You can't add, subtract both sides. You can't multiply both sides. You can't do any of that. We're only allowed to use identities to change the left side. All right. So again, we're trying to make this look just like this. So we want sine. So let's start off by, well, there's a few ways to do this problem. The way that I'm showing it, when I looked at this again this morning, I didn't like how I did it. So I'm going to probably show it a different way. So which is the way we can approach this problem? I'm going to see what your thoughts are. Yeah, it's basically a proof. Any ideas? There's so many ways to approach this problem. And the way that I typed out isn't necessarily the easiest. 1 sine of x plus 1 over 1 sine of x. Yep, that's one way to do it. And can we take out the, you can't. So remember, in order to simplify or cancel out these cosecants, every term in your numerator has to have the same factor. So this term has the cosecant factor, but this term does not have a cosecant factor. So I can't pick and choose this factor with this term. Remember, terms and factors do not reduce or cancel out. It's like probably the number one most common mistake of fractions and simplifying. So Diana, that's one way you can do it, and that's good. I think that's a good way to approach it, and you'll get to the final answer eventually. This morning, when I look at this problem, I thought, you know what, it might be easier just to separate that fraction into two fractions. So how can I write this fraction into two fractions, two-term fractions? Cosecant divided by cosecant plus 1 over cosecant. Yep. Yep, that's exactly how you would do it. I think the way that doing it this way is probably the easiest way to drop. Oh, I dropped my glasses. So rewriting this as cosecant, cosecant divided by cosecant plus 1 over cosecant. So this is probably going to be the easiest way. And I hope everyone understands how I separated those fractions. And going backwards, remember, if you have the same denominators and you're adding fractions, you write it over a single denominator and you just add the tops. Cosecant of x plus 1 is equal to, well, what we started with. So we don't ever, almost never go from this form back to being separated until now, I guess, right? And it looks kind of weird seeing it done backwards like that, but that's how you do it. So then from here, cosecant of x over cosecant of x, what does that become? One. Yep. Yeah, you're dividing by yourself, so, or by itself. Oops. Should probably use the pen tool, not the arrow tool. So this becomes 1, right? And then 1 over cosecant of x. So looking at your identities, what does that become? Sine of x, yeah. Sine of x. All right. So does this equal to what we were trying to get to? It sure does. We just have to just reorder the terms, right? And I think I show that. So here is this step written down here, and then I just reorder the terms to match. So when I saw this problem this morning and I looked at it, I thought, wow, it's probably easier to do it this way. And it's really only it's 2 steps, right? 2 steps. So do you want to see how I originally did this problem? You might think I'm crazy. So originally, this problem could be done. You know what? I think this is from your Learn module. I think I took it from the Learn or Practice modules, and I saw this, and I wanted to go over it because they skipped a lot of steps, but this is what they did. So I guess this really wasn't my way of doing it. Maybe it was. I don't know. So I divided every term top and bottom by the same factor. In this case, I chose cosecant of x. What that looks like is why I did that is I multiplied it by 1. 1 meaning 1 divided by cosecant of x divided by 1 over cosecant of x. This is still equal to 1. So I multiplied the top, both terms by this. So cosecant of x times this fraction, 1 times this fraction. That's why I have it over here. And then I did cosecant of x times this fraction to get it here. So that's how I went from here to here. And I really think your module, one of them, either learner practice, has this example, and they skipped a lot of steps that made no sense. So that's why I'm probably going over it. All right, then cosecant of x over cosecant of x is just 1, so that can cancel out, and I'm left. And then also cosecant of x over cosecant of x is also 1. So let's see what I did this next step. Yep. And then anything over 1 is itself. And we also know that 1 over cosecant, we talked about it over here, is equal to sine of x. So this, after seeing it done this way, which is obviously, it makes more sense. It's easier, straightforward. Seeing it done this way is kind of crazy, right? So again, these problems, there's more than one way to do them. It's kind of how you see them at the time, right? All right. Number 13. Okay, so sine squared of x over tan squared of x equals cosine squared of x. And we want to verify that this equals, well, this. So our goal is to go from here all the way down to here. So I am going to give you 2 minutes. And, a tip I can give you, I said it before, is to get everything in terms of sine and cosine. So start there. Get everything to have sine and cosine only. So I'll give you 2 minutes. Hmm. Hmm. You want a hint? Which identity? Well, just write it because I'm not sure even how to ask my question. Tan of x equals, what is it, sine of x divided by cosine of x, right? Well, the problem is it's squared, right? Yeah, so it couldn't, in an equation, if I square both sides of an equation, and I'm squaring a fraction, don't I square top and bottom separately? Yeah, so I could take this identity and I could square both sides to make it look like this. And that is a true, that's a true statement that is valid. So using this now to help you rewrite this would be helpful. What's our next step then? I think everyone here should be able to do this problem, right? It was this piece that you needed to kind of, fill that gap, I guess, that missing piece. So what's the next step? Well, before we cancel it, we can't. Yeah, remember this is the top. This is a fraction divided by this, so you can't really say cancel sign and sign out. It doesn't work that way because this is this top divided by this entire fraction. And in fact, so you don't make that mistake. Maybe I should have done this to show that it matters, right? Let's multiply by the reciprocal. Yep. You just flip multiply. And then sine and sine cancel out, and that's why you're left with just, well, cosine squared equals cosine squared. So another way we could have done this problem, and I'm just going to start it, I'm not actually going to finish it. When you have like sine squared of x, I could rewrite this as sine of x times sine of x divided by tan of x times tan of x, and then equals the stuff on the right hand side. I'm just going to just go ahead and just write it for completeness. So if you don't like seeing the squares, you can just write them. Remember, square means times itself, right? So it's just sine of x times sine of x. And then seeing it done this way, you can take them individually and change them. So I could rewrite this as sine of x over cosine of x, rewrite this one as sine of x over cosine of x. And then you're going to have this times this over, well, that stuff. And then you would flip multiply and have it all written out again. And then you can say, oh, sine and sine cancel out. Sine and sine cancel out. Then you're left with just, it would be cosine x times cosine x, which is cosine squared. I don't know if that's probably not the best way to approach this problem because you're just making more work by writing them out. Sometimes you have to write them out, though. There are situations, and if you go through those modules, they do examples where you need to separate them for a reason. So, all right. I'll give you a minute for this one. This one is pretty quick. I think this is actually probably an easy one. I'll give you 1 minute for this. All right, time's up. First step, what do we do? brackets. One over cosine. Yep. Let me rewrite it as negative sine of x over cosine of x, and then sine over cosine becomes tangent. So there you go. Pretty easy one. All right, we're almost done, guys. That's my last example right here. All right, let's do this one quickly. I can see a lot of you are falling asleep and want this to be over. Cosecant is 1 over sine. And then cosecant again is 1 over sine. And then we want to distribute the fraction times 1, the fraction times the other fraction. And then that's how you get oh, oops, jumping ahead here. So you get 1 over sine of x plus 1 over sine squared of x equals this. Well, the next step, we want to combine. Let me back up a step because I uncovered too much. Okay, so again, this times 1 gives you this. This times this gives you this. So we should be good on this step. And in order to add fractions together, they have to have the same denominator. So I need this fraction, the denominator, to match this one. Well, this is sine squared of x. This is just sine of x. So I need another sine. So I multiply top and bottom by sine of x. And this concept I'm doing right now goes back to middle school math. So multiply top and bottom by that, and then that's how I get this step. 1 times sine of x is sine of x. Sine of x times sine of x is sine squared of x. This carries down. And now because they match, I can now combine them. So I have sine of x plus 1 in the numerator all over your common, which is sine squared of x, and then we're done. So that goes back to middle school math. And if your teacher allowed you to use calculators to do math, they did you a disservice in middle school, in my opinion. All right. All right, some strategies that we can do. So rewriting is a big one. Rewriting in terms of sine and cosine. Determine common denominators, another good one. Splitting out the numerator. We did that on that one problem. Multiplying by an expression equal to 1. We did that on the previous page. Factoring. We didn't do this one, I don't think, but we could have used it. We definitely use distribution. So, and this is not in any particular order. These are just 6 strategies that you can apply, whether it's all of them or some of them, or even or maybe none of them. All right, so this is going to be overwhelming, difficult, and it takes practice and time. So you really want to go through the modules and work out the examples, but they can take you a lot of time per problem to really understand. Also, looking at, I wouldn't necessarily look at how the module and the learn module solve them. I would write down the problems and I would work them out to see if you get to the same answer they do, because they skip a lot of steps. And when I looked at it, it was a little confusing, some of the things that they did. What's up? No, this is one of the lessons that was super hard. Oh yeah, today and Monday are probably the hardest lessons of this unit. Oh yeah. No, this is not easy by any means. This is complicated. When you first learn it, it's very complicated. Even when you kind of learn a little bit, it still feels complicated and difficult. Take practice. Yeah. All right, guys. Well, thanks for sticking around. And sorry it took way too long. And as always, I hope you learned something.